So let's take a look at the different metrics we have here. So I think there are a lot of different ways to evaluate generated summaries. Like there's what is it called? Semantic similarity, linguistic quality, or compression metrics, and of course, human evaluation. But we have some metrics that really put a number to it, and Rouge is being the first one, which Rouge measures the overlap between the generated summary and a reference summary. So what do you need always? Like when you have test data, you need labels. When you're comparing summaries, you need a good reference summary, oftentimes a human written summary to compare it with, something that you know, okay, this is correct. This is a good summary. This contains all the relevant information I want to have in it. So you need a reference summary, and ROC uses this in terms of n-grams, word sequences, or word pairs. And then we have BLEU, or BLEU, being the second one, which was originally used for machine translation, but it also assesses the precision of n-grams in the generated summary relative, again, to a reference summary. So there's not a lot more theory to this, so let's just try them out and see them both in action, how they compare to each other, and how our summaries will be evaluated. Because we have already created a couple of summaries, so we need that now. Now let's quickly go to use this code here, pip install root score suckerver nltk. This is the template I provided, so it should be already in your template. As you do that, I'm quickly gonna explain the different ROC scores, because there's 3 different ROC scores. We have ROC1, we have ROC2, and ROC-L. So ROC1 measures the overlap of the unigrams to the single words between the reference text, or reference summary, and the generated text, our new summary. And then it indicates how many individual words were matched correctly. Then we have ROC2. You always create all 3 ROC scores. So ROC2 measures the overlap of migrams, so that's pairs of consecutive words. And then between the reference and the generated summary, and then catches the coherence of word sequences. And then we have the ROC-L score, and the ROC-L score is based on the longest common subsequence, also called LCS, between, again, the reference and the generated summary. And this accounts for sentence level structure similarity, while also allowing gaps in between them. So together, these metrics help evaluate the quality of text generation, and higher values indicate better matches to the reference text, to the reference summary. So after we have installed, we do in our imports. So for ROC, we need ROC score import ROC score. And for BLEU, let me quickly think from NLTK, translate, need the BLEU score, and we import sentence BLEU. And we need moving function. Ah, okay. I haven't installed it also. I thought I have done this in Umbrella. But okay. And then we're gonna load our summary. So we have to load our reference summary. We have to load I think we use T5, the big one. We also had an extractive summary. Again, you see that I like doing this because it puts more structure into your code. And then we had one with GPT, I think GPT. Okay. So we've opened data. Let's copy paste it. Okay. Here's the reference summary. You're gonna read it, and it should be encoded in UTF-8. And I'm gonna save it under reference summary. All right. So the T5 summary was, where is it? Summary, yeah. Okay. Then we had an extractive summary. And we had a GPT summary. Okay, so let's load them. GPT-4. Okay. Okay, so now we are, but I loaded them all under the same name. That's not okay. So let's call this T5 summary. That's the extractive summary. And this is the GPT or summary. All right. I'll compute the three ROC scores. So ROC1, ROC2, ROC-L. And we're gonna calculate these three scores for all of our summaries. So we get three different scores. Why is it only three? Because the first summary is our reference summary. So every summary gets compared to this reference summary. So we compare T5 to this. We're going to compare the extractive summary to this summary, and we're going to compare the GPT-4o summary to this. So then we get three ROC scores, and the ROC score is ROC1, ROC2, and ROC-L. Yeah. And here, once again, is a quick summary. What is a ROC score? Probably used Summarizer to do that. So let's first initialize our ROC scorer. Call it scorer. No, that's one. Okay. What do you want to do? ROC 1, ROC 2, ROC-L. Again, here comes the worst stemmer we have already used in our previous lecture, and we set it to true. All right. And now we can compute the scores. So let's get the scores for our extractive summary. Let's call it extractive scores. We also need the T5 scores, and we need the GPT-4o scores. So we use our created scorer, and we use the method score. And this method needs two parameters. First, it needs the reference summary, and it needs the summary that it has to compare to, which in this case is our extractive summary. Okay. Same thing for T5, but this time we compare it to our T5 summary. And same thing for the GPT-4o, but this time we compare it to our GPT-4o summary. And then we need to print the results